Hello YouTube, welcome back to my channel. I am Samarth, and in this video we are going to do some sort of experiment. What we are going to do is we are going to try to visualize an array of numbers, and while we do that we will implement a sorting algorithm on that array. So the sorting algorithm will change the array and we will visualize that array of numbers using some sort of graphics like we have on the screen of this iPhone simulator here. So here you can see that the array is displayed or visualized as bars of random lengths, and the length of each bar is actually its value or the value of the number in the array. And as the array is sorted, you can see that the smaller or lighter colored bars are shifted towards the left and the larger values or the dark colored bars are moved towards the right. Now this is happening, but this is not happening at once. We are implementing some sort of logic so this looks like an animation, and we are also ensuring that we do this using a certain algorithm. So here you can see that if I go ahead and select insertion sort and hit the sort button, the array is sorted using the algorithm called insertion sort, and using this technique you can actually visualize how insertion sort works. You will also be able to figure out how each sorting algorithm works and how different sorting algorithms compare to each other. So here you can see that quick sort is pretty fast, and so is the merge sort. For this video, I'll only be implementing bubble sort, but you can find the code for this project that you are looking at the screen right now on GitHub. I'll leave a link down in the description box below. So without wasting any more time, let's get started. So here I have a new Flutter project. I'll do some cleaning first. I'll go ahead and delete all the comments, and I'll also delete all the UI that I do not need. I'll create everything from scratch. So now that I have cleaned up the project, you can see that the scaffold has a body which is just a container as of now. So we are starting from scratch, and again for the sake of simplicity, I'll be doing everything inside main.dart file, but I do not recommend doing it if you are working on a real project. Alright, so first things first, what I'll do is I'll start by creating two buttons at the bottom of my scaffold. So I can use the property bottom navigation bar, which is a property of the scaffold, and this will be equal to a row. And this row will have two children. I'll wrap each one of these inside an expanded widget, and the child of these expanded widgets will be flat buttons. So this is the first one. The child of this flat button will be a text, and the text will be randomize. We'll use this button to generate a random array every time we want to start the sorting algorithm from scratch. And I'll just go ahead and copy that and paste it inside the row as its second child, and I'll change the text to sort. As I save it, you can see that I get these two buttons down here at the bottom, randomize and sort. So let's wire up these buttons to their respective functions. So I'll define the onPressed for the flat button, which says randomize, and I'll set it equal to a function called randomize. We'll create this function in a moment. For the second button, which says sort, we will have another function called sort. Now we just need to create these two functions so that we get rid of these errors here. Alright, now we do not have any errors, and our buttons are now tappable. You can tap on them and you can see this splash effect right there. Okay, moving on. Now we need an array, so I'll just go ahead and define a list of type int. Okay, and let's call this list as numbers. I'll initialize it to a blank list, and inside the randomize function I'll use a for loop, and I'll generate some random numbers and fill this numbers array with those random numbers. We'll also have to fix on some numbers like a sample size, total length of this array that we want to have. So let's just have 500 for now. And now I can go ahead and type in a for loop here. The loop will start at 0 and will go up to sample size. And now here what I'll do is generate a random number and add it to the numbers list. And I can do that using just one line of code. numbers.add random, which is a function that is available inside the library Dart math. So I'll import that, and on this I can use the nextInt function to which I'm passing 500, which is again, I can replace it with sample size. So this function will generate 500 random numbers under the value 500, and then we will have those numbers inside the array numbers. Finally, we can go ahead and call setState because later we'll be using this numbers array to draw our lines. Let's go ahead and write the init state as well. So we need init state to call the randomize function for the first time the app launches. Okay, so now remains the rendering part. So we need to write some code to render out these numbers as bars, and the length of each bar will be corresponding to the value of the number on a particular index in the numbers array. So there are 500 numbers in the numbers array. So we'll have 500 bars, and the length of each bar will be a function of the value stored at a particular index. So the 0th index value will affect the first bar. And to do that, first I'll be creating a row inside my body, because I want to have a row of widgets spread horizontally across the screen. So the child of this container will be a row, and this row will have children. It will have 500 children to be precise. And to generate these children, I'll be using the numbers array, and I'll be calling the map function on this numbers array. For each iteration, I will have access to the number at a particular index, and on this I'll have to call toList to convert it back to a list that I can pass into the children property of the row. Now from here, I'll have to return a widget. So what I'll do is I'll start by returning a CustomPaint widget. A CustomPaint widget is a widget that takes in a painter object, which should extend the class CustomPainter. So I'll just call it bar painter for now. It doesn't exist as of now, but we'll create it in a moment. To this, I'll pass in a few properties. The first one will be the width. So let me just give it a width of 2 units. Then it will have a value, which you can also call as the height of the bar. So let's just pass in number right here. And then finally it will have an index, which tells us the position of that particular bar in the whole array of bars. I'll have to use a variable, let's call it counter for now, and I'll just go ahead and create the counter variable right here, and I'll set it equal to 0. And inside the map function, I'll increase the value of counter. So every time this map function executes for a particular number in the whole array, the value of the counter will be increased, and starts from 0 and will go up to 500. So now we need to create this bar painter class. So I'll scroll down, reach towards the bottom, and create this new class called bar painter. It should extend a class called custom painter. And I'm getting these errors because any class that extends the custom painter class needs to have 2 functions that you actually need to override, and these are the 2 functions. So there is a function called paint, which actually does all the drawing and painting. And there is also this function which is should repaint, which is just an optimization function. So for this video, we can simply return true from this function without having to worry about it much. And in the paint function, we'll be writing the code to draw whatever we want using the values that we are passing in to the bar painter class. So we are passing in 3 different values: width, not widget, value, and index. So width, value, index. Let's go ahead and receive those values. So if I save it right now, you'll not see much on the screen here, but let's just go ahead and add some code to the paint function so we can start seeing something happening on the screen on the right. So first of all, I'll define a paint object. This will be a new paint object, and on this paint object, I'll set a few properties. So the first thing I'll do is set a color, and I'll give it a color red. I'll also set the stroke width to something like 5 units, and I'll also set the stroke cap to stroke cap.round. You can have it square as well. It's a personal preference. Now we need to write some code to draw a line from this coordinate to a coordinate that we can find out using the value that we are receiving in. So what we have to do is just use the canvas object and use the drawLine function. And as you can see, that drawLine function takes in 2 arguments, 0.1 and 0.2, which are basically just offset objects. and pass in the paint object that will be used to actually draw the line. So point 1 will be an offset. So let's pass in an offset here, takes in an x and a y value. So the x will be index into width and y will be 0. For point 2, the x value will be the same, but the y value will be equal to the value. Okay, and since this is an integer, we need to convert it into a double, and for that I can use a function called seal to double. So this will give me a double value, and if I save it, and let me just hot reload, you can see that I get these bars. All the bars are of the red color, but the length of each bar is different. And you can see that if I hot reload again, a new array is generated every time with random numbers, and therefore the pattern of these bars differs every time I hot reload the application. So now we need to write the sort function. The sort function is going to be very simple. We are going to implement a simple bubble sort. So I'll go ahead and paste some code that will loop over the numbers array and will sort it using the bubble sort algorithm. And there we have it. So this simple algorithm will sort the array numbers using the bubble sort algorithm. First of all, I want to set state after sorting is done. So I'll save that. And if you go ahead and try this out right now, you can see that the array is sorted in an instant. You do not even get to see how the sorting worked. So if I go ahead and sort, you can see that it's sorted almost instantly. So we need to add a delay inside our for loop so that we can actually see the sorting happening. So for that, I'll use an await future.delayed function, to which I can go ahead and pass in a duration. For now, I'll go ahead and add a duration of something like 500 milliseconds. Okay, and since I'm using the await keyword here, I'll have to use the async keyword on the sort function. And I'll also move this set state inside the for loop. So for every iteration of the inner for loop, I'll be updating the state, which will call the build function and rebuild this whole scaffold with the new data inside the numbers array. So let's go ahead and save that and hot reload the application, and I'll hit sort. And you can see that the array is being sorted and it looks like an animation. And there we go. So a few things you can do to play around with this. First of all, you can go ahead and change this time value, increase or decrease it according to how you want your animation to look like. And you can also change the algorithm. So instead of using bubble sort, maybe you can go ahead and play with other sorting algorithms like selection sort or insertion sort, which are really simple. And if you really want to challenge yourself, you can go ahead and implement more complicated algorithms like merge sort and quick sort. So the sorting is done, but our randomize function is still not working, and that's probably because we have not reset our array inside the randomize function. So I'll do that and I'll save it, and when I hit randomize, you can see that the array is reset. So every time I tap on the randomize button, the array is reset and I get to see the new pattern that I'm building using the custom painter. Now what I want to do is add a few more colors to these bars, and I'll make the color a function of the value. So if the value is less, I'll give it a light green color like I have here in the demo. And if the value is more than a certain value, I'll give it a darker color. And here I have a total of around 10-11 colors. So I'll copy the code for that and paste it right here where I define the color for this paint. So instead of having just the red color defined for the paint object, I'll go ahead and paste in this if-else ladder. So if the value is less than 500 or something like that, I give it a light green color, and as the value increases, I move the color to a darker shade of green. So eventually I have this very dark color. You can choose to have your own colors, it's completely your choice. And now if I save it, you can see that I get these bars, and each bar is of a different color and a different length. I'll also fix one more thing. Instead of defining the stroke width as 5.0, I'll define the stroke width equal to the width that we are receiving as an argument inside this class. Let's save that, and now you can see that the bars are much thinner. So if you reduce this number, you will have thinner bars, and as you increase this number, you will have thicker bars. So it's completely up to you how you want your animation to look like. I think that 2.0 is a pretty good value, but instead of having a static value, what I want to do instead is calculate the width of these bars dynamically based on the width of the screen and the number of bars that I want to have. And I can do that very simply using media query. So I'll find out a number for the width of the screen and divide it by the sample size, and that will give me a perfect number that I can use for the width. So if I save it right now, you can see that this is the perfect width, which allows us to look at each and every bar on the screen. So this is perfect. Let's hit sort and see how it works. So you can see that it works just fine. Now, if you have noticed, it looks a little laggy. It's not as fluent as I have in the demo. And that's because whenever you call set state, like you are calling here and here, it calls the build function of the widget inside which you are calling the set state function. So for us, we are calling the set state function inside the my homepage widget. So the build function of this widget will be called again, and everything inside the build function will be rendered again. Okay, although there might be some internal optimizations in Flutter's underlying framework, but the bigger picture is that every time you call the set state function, the whole UI of the particular widget is rebuilt, which can be a lot of work and which can be really painful for the app. So here you can see that I'm calling set state once for the randomize function, which is okay. But inside the sort function, I'm calling set state every 500 microseconds. And I'm doing it a lot of times, so the app has to rebuild the whole widget tree every 500 milliseconds, and it has to do it for a couple of thousand times, which is not good. You don't want to build the whole widget tree. Now in our case, we don't have much except the row which we want to rebuild. We just have this bottom navigation bar and this app bar, but in a real application you might have more widgets and you don't want to rebuild everything over and over again. You just want to rebuild the part that requires rebuilding. In our case, this row is the only widget that requires to be rebuilt every 500 milliseconds. So why not use streams instead of calling the set state function, because that's what streams are built for. They allow you to get updates in real time, and you have a widget called StreamBuilder that allows you to use streams to update a particular part of the widget tree instead of updating the whole widget tree. So I'll wrap this row inside a StreamBuilder, and to the stream I'll just pass in an object called stream. It doesn't exist as of now, so we'll go ahead and create that. So I'll scroll to the top, and here I'll define a stream controller first and a stream object. And both these, the stream controller and the stream, will be of the type list of type int. Okay, it's good to define all the types, otherwise your application may complain when you try to run it. Now inside the init state function, I'll initialize these objects. That's it. Now inside the randomize function, I'll comment out the set state function, and instead what I'll do is add an event to my stream controller. So I can go ahead and call stream controller.add and pass in the whole numbers array. I'll do the same thing right here. So I'll just comment out the set state function and add the numbers array to our stream controller. Perfect. Let's save that and see if we have any improvement in the performance. So I'll refresh the application and I'll just go ahead and hit sort, and it just goes white. And this is because the build function is not being called over and over again anymore. The build function is called only once, so the counter variable is defined only once. Okay, now we need to move this to a place where it can be redefined over and over again, and that place is inside the builder of our stream builder. And this is again a proof that using a stream builder prevents our build function from being called over and over again. Instead, the builder is being called over and over again. So let's save that and hit randomize and hit sort again. And this works just great. You can play around with this time if you want to, and it will give you different results. You can implement different sorting algorithms to play around and learn visually how different sorting algorithms work. It can be really helpful for you to understand how these sorting algorithms work, and it will also allow you to write better algorithms if you are able to implement all these algorithms. So if you have built something really cool using what I have taught you today, make sure you share that with me. I'll be really happy to look at it. And you can find the code for this whole project that I have here on GitHub. It has all the different sorting algorithms that I could implement in my free time. And if you want to make an improvement to this project, feel free to make your contribution. If you like the video, give it a thumbs up. A thumbs up tells me how much you are appreciating the work that I'm doing. And make sure that you leave a comment, because I make sure that I go through all the comments on all my videos. Thanks for watching.